of these, we are basically plugging into that negative b plus or minus the square root of b squared minus 4ac all over 2a. So what this gives us is the, what does it give us? The zeros, because these are functions, right? And the zeros of the function end up being the x-intercepts of the graph, don't they?
Yes.
Yes. So when we simplified this one, on this one, our discriminant was 64. That is a positive perfect square. Did I get 2 rational answers? Yes. Okay. On this one, my discriminant was 28. It's positive, but it's not a perfect square. So did I get 2 irrational answers? Yes. Okay, this one, my discriminant is, should be 0. Yes, my discriminant is 0. 9 minus 9. Did I get 1 rational root? Okay? So see how that relates. Any questions about any of these? Yes, sir.
Number 2, shouldn't it be b squared? So wouldn't it be 16 minus 4?
What we did on this problem was, we cheated a little bit. Do you see it has a common factor of 2?
Yes, ma'am.
You can either do it with this is A, this is B, this is C, or you can divide out that 2 or factor out that 2, and this is A, this is B, this is C. And you should get the same answer either way.
Where's the 2?
What would happen if we didn't factor it out is we'd end up with 4, and you'd end up with, probably 4, 4, and 4. Did you end up with 4, 4, and 4?
Negative 4 plus or minus 16 over 7.
Yeah, that negative 4 plus or minus 4 root 7 over 4 is what you would have ended up with if you didn't factor out the 2. And it simplifies to the exact same thing because 4 divides into all of those terms.
Just 2 expansions.
Good question. Any other questions? Okay. Now, this one had 2 equations in it. Okay? So, on the first one, it didn't tell us how to solve it. So, I just decided to set it equal to 0, move the 16 over, divide by 16, take the square root, and I got plus or minus 1/2. And so the negative 1/2 makes no sense. So I'm going with positive 1/2. And then to find the distance, it's a second equation. The first one is is it the height with respect to time? Yeah. How high was the newspaper off the ground with respect to time after we threw it? That's what that first equation is. The second equation tells us about how far, the distance that we threw it. So if we can figure out how long it took it to hit the ground, which is a 1/2 second from solving this first equation, then we plug in a 1/2 second into the second one, we know that our toss went 15 feet. Does that make sense?
Yes.
Okay, cool. So we could do the same thing with the second one. Now on this one, I chose to divide out the negative 4 and then factor it. Did you choose quadratic? I bet you did, because your brain was in quadratic mode. Quadratic formula. So we got 2 answers, positive 1 and negative 1/4. The negative 1/4 makes no sense. So once again, we plug the 1 into the distance formula, and we get that the paper went a distance of 30 feet this time. I'm glad we don't have to do anything heavy today, because you guys all look exhausted. You are due a 4-day weekend.
Yes.
Awesome. I'm excited for you. I'm excited for my 3-day weekend.
I'm due for another summer.
Okay, guys, this is in your geometry book. It's on page 544, so no need to write it down. But this is a summary of all the ways we have learned to solve quadratic equations. Now, we know how to graph a quadratic, don't we? And so, if it were set equal to 0, that would give us the zeros, or those x-intercepts, right? Okay, we know how to factor to solve. We know how to take, if it's already written as a perfect square, take square roots of both sides. Now, we usually would see that quickly if we had something like this. 9x squared equals 25. We would go, ooh, divide by 9. And take the square root of both sides. And when we take the square root, we get plus or minus. And the square root of 25 is 5, and the square root of 9 is 3. So that's usually when we see it quickly. But if they've already completed the square for us, and we have a binomial squared equal to a number, we could just jump right in, take the square root of both sides, and finish.
Wow.
We know how to complete the square. Now, unless forced, we're only going to choose completing the square probably if the leading coefficient is a 1 and this middle term is even. If the leading coefficient is something besides a 1 or the middle term is odd, probably going to use quadratic formula. So this is kind of, for me, this is how my brain would think. I would probably check for square roots first. Then I would see if it factored quickly. If it had an even middle term and a leading coefficient of 1, I might complete the square. And then finally, I would go for quadratic formula. We know this one always works. I would only use graphing if somebody gave me the graph. Or it was a really ugly equation and I knew how to find the zeros on my graphing calculator. You might learn that soon. Okay? Now, this completing the square, you see I've started. Completing the square is important for conics, though. So, quadratic falls under the heading of parabola, which is one of our conics. So we are going to be revisiting this completing the square, so we can't forget it. But we don't always have to use it because we have this quadratic formula that will always work. Okay, now, yesterday, we looked at the discriminant. Let's tie it all back together today. If we started out with an equation, so that would be if we had y equals here, like we do down here, and we were finding the zeros, we could plug it in to the quadratic formula. In this case, if it's flowing from there, that would be the roots because it's an equation, right? Zeros down here. All right, so we get the roots are -1 and 3. Now, when we have two roots, which ends up giving us the two zeros, that tells us that our graph is going to cross in those 2 points, doesn't it? So let's think about, we talked about a couple times, when it's 0, that means it's going to touch in just 1 point. But if it's negative, if there are no real roots, there are only complex solutions, it's not going to cross at all, is it? It's going to be a quadratic that is above the x-axis and opening up, or it could be a quadratic below the x-axis and opening down. If it were negative, yeah. This would have to be like a negative. Okay? So these, when we get a discriminant that's negative, it tells us there's no real solutions. But it also tells us something about that graph. We know the graph is not going to cross the x-axis if there are no real solutions. So it's got to be one of these cases. On this one, when we think about its function, if we think about the function that involves this part of the equation, we know it touches once because it has one real solution. This one, we got a discriminant that was positive, and it's always going to cross twice. Do we see how they all tie together?
Yes.
Okay. You don't have to write this down either. This will be in your notes, so if you want to print it out later on. I took this off the Purple Math website. So give them a shout out for that. This is from Purple Math. Shout out to Purple Math. That's right. So I had the link on there with that it disappeared somehow. Okay. All right. So today we're going to practice. We're going to practice. Now this says use the quadratic formula. So today we're going to practice with the quadratic formula. But as we move on, I want you to think, which method is best? If it factors, we better factor because that's quicker than quadratic formula. If it has an even middle term, you may want to complete the square. Now, some of you might have an aversion to completing the square right now. We'll correct that when we get in the conic unit. We'll come to love completing the square eventually. But think about all the different methods we have and choose the best one for you. Okay, so we're out of our textbook, and these are our problem numbers. I'm going to leave this up here for a second. And then I'm going to upload this to my website. So you can just open it up on your technology. It'll all be there together, and you don't have to go to the book website. Okay?
Is this the homework class?
It is listed as homework on your calendar, but you have
The rest of class?
the rest of class to work on it.
So we should.
So no one should have homework if they use their class time wisely. So, that was your shout out, wasn't it? All right.
She doesn't know. Hi.